visiting the solar system is very similar to what it used to be like visiting the other continents on our planet. They were very, very long voyages. You didn't quite know what was going to be there when you got there. You had to take all your food, all your fuel. You didn't always know whether you'd come back or not. And today, solar system discovery has been very similar. Obviously, we haven't managed to send astronauts all across the solar system yet, but it might be something that happens in your lifetime. And someone once told me that sending a satellite to Saturn, for example, is very similar to getting in your car, driving it from John O'Groats to Land's End, leaving it there, running, going back to it in 20 years, and still expecting it to be working, functioning, and perfect condition. It's exactly the same. The only difference is if we send a satellite to Saturn, we can't go back in 20 years to check it's still working. We just have to hope it works, and hope it works well as well. So the first little quick demo, this is kind of cheating because it's not completely relevant to solar system science, but we need a way of getting there. So what I've started with is a tea bag. I cut the top off and I emptied the tea out, and I'm going to just put it on the table here. And this is just a little way to get in our rockets and go across the solar system. I don't know if anyone's seen this before. I had to buy 250 of these tea bags because I love doing this so much. And they're fair trade organic tea bags as well, which is a bit annoying because they weren't cheap. So that's our little rocket ship off to, off to the solar system, just to get us started. Okay. So today, yeah, that's just the ash coming down. Today we're going to visit all the planets in the solar system and some of the other things in the solar system as well, such as comets. And we are going to end up talking about exoplanets and what kinds of solar systems there could be outside of our own. And this is just a little portrait of the solar system here with comets and asteroids and galaxies and all the planets, and Pluto's still in there because it's a small planet, but I think it's still a planet. I know I'm an astronomer, but it's still a planet, come on. So yeah, that's the solar system we're going to be visiting. The very first thing I need to do is show you that even though we have pictures like this of the solar system, we could never actually see that with a camera because the scale of the solar system is just ridiculous. And the only way that I can show you what the scale of the solar system actually is using one of these. Yes, I know it's a toilet roll. I need a volunteer. Go on. Can you come and be the sun? So if you are the sun holding on to the end of the toilet roll, you can see from our list that Mercury is about 3.5 sheets away from the sun. So that's 3.5. Does someone want to come be Mercury? Yeah, come on then. So if you go this side, then you can face everyone. So just about there.
Yep.
Okay, and then Venus is 3 and a bit sheets away from Mercury. Can I have a Venus? Go on then, yeah? Planets are disruptive, aren't they? So how many? 3 and a bit, so about here. Okay, then Earth is 2.5. So who wants to be Earth? Go on then. Just to wake you up on a Sunday morning. Brilliant. And 4.5 row from 1, 2, 4, 4 and a bit. Who wants to be Mars? Go on then, you were first. You're all on video, I hope that's okay. Okay, brilliant. Now, as you can see from our little list, those are just the inner planets, the rocky planets with the sun at the end there. Jupiter, the next one along, would be 34.3 sheets, and I didn't bring enough toilet roll. Neptune would be 101 sheets away, so that's the edge of our solar system. So you can see how far apart all the different planets and all the different bits of our solar system really are. That is just the inner solar system. So in order to get to places like Saturn and Pluto, you can tell it's very, very far away indeed. Thank you very much. Can we have a round of applause for our planet? So these are our 4 inner planets. The rocky planets Mercury, Venus, Earth and Mars, and you can see that Mercury is very small. In fact, there are some moons in our solar system that are bigger than Mercury. Then we have Venus and Earth, which are very similar in size, and then Mars, which again is quite small. And we don't know that much about Mercury, partly because it's so close to the Sun. If you look at it from Earth in a telescope, the Sun always blinds your view. You shouldn't ever look at the Sun through a telescope, by the way. But there is a couple of satellites, one that's got to Mercury already and one that's hopefully on its way soon, that are going to map the surface and look at the geology and the composition and hopefully find out more about Mercury in the years to come. We know about 40% of the surface, 45% of the surface, and after these 2 missions, one of which is the Bepi-Colombo mission, after those, hopefully, we should know a bit more about Mercury in years to come. Venus is often called Earth's twin because it's very similar in size to Earth, but it's covered in a really dense, thick, horrible cloud, which is actually very acidic, very sulfuric. And because of that, on the surface, we believe it's actually more like Earth's evil twin. It's not a very pleasant place to be at all. The cloud is so acidic that, in fact, if we sent humans to Venus, obviously without a spacesuit, if we inhaled that cloud, our lungs would melt, which isn't very pleasant at all. And the other thing is, because of this really thick, dense cloud, the pressure on the surface of Venus is 90 times stronger than the pressure on the Earth. And I've got another quick little demo. I need 4 people this time. The first 4 people to come and grab one of these. We've got ordinary, tiny little marshmallows here. And just pretend that these are our astronauts. So what I want you to do is take the end off the syringe, put an astronaut in the bottom of it, and then push it all the way up. Oh, they're a bit stiff. So you've got almost no air left in the syringe. Yeah. And then put your thumb over the top of it to block the air, and then pull. So what you're doing is essentially making the pressure really, really low. And what happens to your marshmallow? Can you see? It's got a bit bigger. I know it's not a very dramatic demo, but what this shows you is that if we went to a planet that had less pressure on the surface, without a spacesuit again, your astronaut would swell up and might even explode. Now take your thumb off, and what happens to the marshmallow? It goes tiny and wrinkly and all like squished, basically. That's what would happen to you if you were an astronaut on Venus. Instead of exploding, you'd implode. Okay, this little guy here, he might look like a Dalek, but he was actually one of the first ever planetary satellites. He's called Venera 1. He was built by the Russians in the 50s or 60s. I can't quite remember the date now. And he was the first satellite that was supposed to go to another planet. So he was quite an important thing in the world of planetary science. Unfortunately, he didn't actually get there, but a few years later, the Russians made Venera 7, which did actually get to Venus, and it was amazing because this is the first time human beings had ever touched down on anything outside of the Earth. So not as exciting as a Dalek-looking satellite, but equally important in the world of planetary science. So the Russians have got something to say there as well. And now we have things like Venus Express orbiting Venus. Venus Express is interesting because it was made from flight spares of a spacecraft that's orbiting Mars at the moment called the Mars Express. And whenever we build spacecraft, we always build at least 2 of every component and put them all together just in case they blow up on the launch pad or if something goes wrong. So from the flight spares of the Mars Express, the Venus Express was built. Obviously, it had to be changed a little bit because Venus is that much closer to the Sun and because of the atmosphere and the pressure at Venus. So it's slightly different to the Mars Express, but it was actually built from the flight spares. So that just shows that we don't waste everything that we build in the space industry. So that's cool. And now we move on to the Earth and the Moon. I'm sure you've all seen a picture like this before, with the Earth with the Moon behind. I always kind of cringe a little bit when I see pictures like this being used, because it's really misleading. It looks like the Moon and the Earth are really, really close together, and in size-wise, you can't really tell the scale between the Moon and the Earth either. This is more realistic. The Earth is here, and the Moon's there, and you can see the Moon's about a third of the size of the Earth, and it's actually really, really far away. Bearing in mind that the Moon is one of the bigger moons in the solar system, especially in relation to the Earth, and also bearing in mind that human beings have only ever been this far out in our solar system. Yeah, sure, we sent stuff to the outer solar system, but as people, we've only ever been to the far side of the Moon. You might start to feel a little bit insignificant, especially when I show you the next set of pictures. This is what the Earth and the Moon look like from Mars. So we're getting a bit smaller, getting a little bit more insignificant. That dot there is what the Earth looks like from Saturn. You can see the rings in the edge of this picture, and that's it blown up. So it really is like a little blue dot. And then you might have seen this one before. This is what the Earth looks like from the edge of the solar system. Hands up if you're feeling insignificant. Couple of you. I thought there'd be more, but hey. So that those of you that are feeling a little bit insignificant, don't worry, because we've made our impact on the Earth. You know, we might be tiny little creatures on a tiny little dot in the solar system, but every single one of these dots in this picture are artificial satellites that we've put in space. So you can see they do swarm the Earth in low Earth orbit and in further orbits as well. So even though we're insignificant in the solar system, we're not that bad in terms of Earth. Moving on now to Mars. Mars is not as hostile as Venus. It looks kind of boring in a way when you look at it on this picture, but it is interesting. It's got some massive volcanoes on the sides and these big scars, which are valleys, rift valleys, across the surface. And some of these pictures are taken by the Mars Express, which I talked about before. Slightly enhanced, I think, these ones, but you can see the rift valleys and how wide they are and how high the volcanoes are. And Olympus Mons, which is the highest volcano on Mars, is 35 times higher than Mount Everest. So you can see how big it really is. And this just shows, this is supposed to be Mount Everest here and Olympus Mons in the background. So for a planet that looks kind of boring, actually has got some really interesting features on. And we know a lot about Mars because we've sent a lot of spacecraft and rovers to Mars, and this is Spirit or Opportunity that they stopped working a few years ago, but they took some brilliant pictures while they were up there. Tyre tracks in the surface of Mars, which just looks like a desert on Earth. And this picture is supposed to show the Victoria crater on Mars, and there's supposed to be a little dot there, which is one of the rovers, and that was a picture taken from space, but you can see a man-made object on the surface of Mars on there, so that's pretty cool. And we have seen so many pictures of things like this on Mars, and at the moment what we think they are dried up riverbeds. The kind of shape that you see looks very much like a riverbed. And what we're able to do with pictures like that is back project them and try and work out what Mars could have looked like if it did have water on. So that's kind of what we think Mars could have looked like if it had water on. Not saying it doesn't have water on now, it probably doesn't, well, not in liquid form anyway, but if it did, you can see it actually looked a lot like Earth a long time ago. And as a scientist, especially a planetary scientist, we're always asking the sort of questions about life. Could there be life on these planets, or could there have been life on these planets? And that's one of the things that the Curiosity mission is hoping to find out in due course. The Curiosity rover was sent to Mars last year. It got there in August of last year, and it's been sending back some fantastic pictures ever since. It's a rover. It's about as big as a Mini, so it's pretty massive, and it was built, it's a NASA spacecraft. It was built at JPL, and this is a picture of it having its final touches at JPL. And it's got these big, thick tyres to contend with the sandy surface of Mars. And in the tyres, there are ridges cut into it. And one of the things I quite like are the shape of the ridges. As it tracks along, it makes these funny footprints in the surface of the planet. And part of that is to see how far it's going and be able to measure things. But the other thing it does, which I think is quite funny, is it imprints a Morse code into the sand, and that Morse code actually spells JPL, 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 which is where it was built. So the scientists have got their little twist on it there as well. And this was an incredible descent. It used something called a sky crane. So the main bulk of the rover parachuted down to the surface of Mars, and just before it got to the surface, these cables came out and stretched out and lowered the rover down onto the surface. And this was the first time this had ever been used somewhere other than the Earth. It used to be a military design for sky craning packages to, war zones and stuff, but it had never been used on another planet before. And the only reason the reason it was used was because Curiosity is so big. The hope was that you can't use airbags and all those other sorts of things, but if you could sky crane it down, you can make a massive rover with loads of science on it. And I remember hearing about the plans of this when I was working at my lab, and people were laughing. People were actually genuinely laughing, thinking, there's £1 billion rover here, and you're going to lower it down on a crane. Preposterous, almost. And nobody could see any of the plans or the blueprints for how it was going to work, because it's a military thing on Earth, and the military didn't want to divulge any of their secrets. But I watched the launch in August last year, and it was incredible. Obviously, there wasn't a sort of blow-by-blow picture of it, but the fact that it functioned and it worked and everything worked perfectly, and it's been sending back images and data ever since, it just shows how incredible humankind can really be when we put our heads together. And these are just some of the initial pictures the Curiosity took. The mothership took this one of the Curiosity parachuting down onto the surface of Mars, and then that's a foot of the rover next to a rock, and there's the shadow of the rover with some mountain ranges in the background. On the left we've got a sunset on Earth, and on the right we've got a sunset on Mars, and that shows that sunsets on Earth are red, but sunsets on Mars are blue. And in the daytime on Mars, the sky is red, so it switches round, which is kind of bizarre. If you wake up in the morning and the sky was bright red, it would be a bit weird, especially if the sunsets were blue. But that's the sort of things you'd see if you lived on Mars, and that might sound like a silly thing to say, but if we are going to send people to Mars as for a long-term type thing, these are the kinds of things that might screw with their heads and that might, drive them insane on Mars. So you have to think about these things. And the reason it's blue on Mars as opposed to red like on Earth, it's actually the same reason. It's the way that light's refracted through the particles of the atmosphere. But the atmosphere is made up of a different substance to what it is on Earth, and so light's refracted in different ways. So it's the same process, it's just slightly different to what it is on Earth. Okay, moving out to the Cassini system, the Saturn system, which has been visited extensively by the Cassini spacecraft. We know quite a lot about Saturn, mostly due to the Cassini spacecraft, which has been there since 2004. And is still functioning very well. Cassini was built in the late 90s, took about $3 billion, which is a huge amount of money then. And it's about the size of a school bus. You can see some people down here for scale. And it's got over 18 instruments on it, measuring all kinds of things from obviously taking pictures, measuring the dust around Saturn, the magnetic field, the infrared. This bit here was incredible. That's the Huygens probe, and that detached from Cassini and landed on Titan, which is one of the moons of Saturn. And that was the first ever time anything from Earth had ever landed on somebody else's moon, so that was pretty impressive as well. And the data and the pictures that we've had back from Saturn and from the Cassini mission have been quite astounding. So we know quite a lot about Saturn. We know it's about 10 times as wide as the Earth, but because it's primarily made from hydrogen and helium, it's very, very dense. So if you could find a swimming pool or a massive bath to float Saturn in, I know this is a bit silly, but If you could, it would float because it's less dense than water, which I think is quite cool. And Saturn's obviously famous for being the original Lord of the Rings. Where there's a picture here of the rings sort of swooping out with a small moon here. And the rings are very, very, very wide, wider than we first thought actually. But they're very, very thin. And in this picture, that thin black line there is the ring's edge on. And because Cassini's been visiting Saturn for such a long time, we've managed to see all these different phases of Saturn and different seasons as well. So it just shows how important long planetary missions can be as well. And Saturn's also really important, not just for the rings, but for its moons as well. And I've already mentioned Titan here. Titan's bigger than Mercury, so it's a massive moon. And Saturn has over 60 moons, and each one is incredible in its own right. This top right picture here is a photo of Titan. That's the one that was visited by the Huygens probe, which is why we know a fair amount about it. Titan is incredible because it's the only other object in our solar system that we know has lakes, rivers, rain, maybe even rainbows on it. It has a weather system and it has liquid on the surface. And that's the only other place we know in the solar system that has that. The difference is, for Titan, it's not liquid water, it's actually liquid methane, which has a little bit of a different slant on it. If you're thinking about pretty rainbows made out of liquid fart, not so pleasant, but still, it's still really important. And because it's so big and because it's got these ponds of methane in it, it's kind of similar to what primordial Earth could have been like. So it's quite important for us to know what Titan's like, because if we could visit it in some million years, we don't know how it might evolve. It might evolve into something very like Earth. Saturn has more interesting moons. There's Hyperion, which is basically a massive lump of coral floating about in space. It looks like a sponge, and it's made out of very, very porous rock. And it's just such a weird shape. That is orbiting Saturn. I mean, imagine if our moon looked like that. It would be quite weird. And then we have Mimas, which is one of my favourites. Mimas has a massive crater in it, the Herschel crater. It's about a third of the size of its moon. And if we had a crater like that on the Earth, it would completely wipe out Australia. That's how big it is. So ignore all the stuff that's going on in Russia and stuff like that at the moment. Just think about this poor little moon. And on the other side, where the crater, the opposite side to where the crater is, there's massive fissures in the side of the moon, which, because of the collision, it just sent shockwaves through the whole moon. And it could have exploded it completely, but luckily it didn't. And one of the reasons it's my favourite moon is because it looks like something in science fiction, and I love it when science fiction and science fact come together. Anyone guess what it is? Yeah? Yeah, the Death Star. It looks really similar to the Death Star. But George Lucas has assured us that he designed the Death Star 3 years before the first close-up picture of Mimas came about. So he thought of it first, and then nature came second. Don't know if that's true or not. Another one of my favourite moons of Saturn is Enceladus. And Enceladus is actually really tiny. It's 1/230th the size of its parent planet. So if you imagine Enceladus was your thumbnail, Saturn would be about the size of a double-decker bus. So that just shows how small Enceladus is in relation to its parent planet. But it's really, really important. It's so small, but it's really important in the Saturn system. It's covered in ice, absolutely covered in ice, but at the South Pole there are cracks in the ice. There's cracks and fissures, and from these cracks there is something pretty amazing being ejected. Liquid water. So forget looking for liquid water on Mars or anywhere else in our solar system. We have liquid water at one of the moons of Saturn. And because of this ejector, because of this plume of water coming out of its south pole, we've done all kinds of mathematical models and thought of all kinds of different bits of science. And the only conclusion we can come to for this plume of water coming out of Enceladus is that it actually has a liquid water ocean underneath the crust. And one of the future missions is to send a probe to Enceladus and drill down and try and measure that water. And one thing we do know actually is that it's salinated water, it's salty water. So there's a salty water ocean on Enceladus. The only other place I know that there is a salty water ocean or oceans is Earth. So it's a prime candidate for astrobiology. If we could go to Enceladus and drill down through the ice, we really don't know what we might find, because there are microbes and extremophiles that can live under thick ice in the Arctic and Antarctic on Earth. So who's to say there isn't stuff swimming about in the oceans of Enceladus? Okay, I've shown you a bit of this picture already. It's the one with the Earth in. But the reason I'm showing it again is because this actually shows the rings in all their glory. So what's going on in this picture is the sun is behind Saturn, so the planet itself is in shadow. But because the planet is in shadow, it's showing up all the rings. And you can see the main rings here. These are the ones made from rocks and dust and tiny fragments. But then there's this big wide ring here. That's called the E-ring. And for years and years, we didn't know why the E-ring was there. And also it's made from water vapor, ice, and tiny little, it's not made from anything like rocks and dust like the other rings. And we just didn't know why it was there. It was in 2005 when we found out that Enceladus had its plume. When we found that out, we realized the reason the E-ring is there is because tiny Enceladus is shooting water and ice out from its plume, and as it orbits Saturn, it actually creates one of the rings. So it's so small that it creates one of Saturn's rings, which I think is really cool. So I big up the small people. That's good. Okay, moving on to Jupiter. What I've done with this picture is just rotated it 90 degrees, so you're looking at Jupiter on the side. So the middle bit's the equator, and these are the two poles here. And this picture was actually taken by the New Horizons spacecraft, which is on its way to Pluto. And this is an enhanced colour image, but it's not false colours, it's all real colours. So if you could float past Jupiter now, this is basically what you would see. And you can see in the clouds, there's loads of different structures. There's these small whirlpools here, and there's these bigger, they're called herringbone clouds here. And the brighter bits are called zones, and the darker bits are called belts, I think. I might have got that the wrong way around. No, the lighter bits are zones and the darker bits are belts. And the reason the belts are darker is because the cloud is thinner, so there's less cloud for the sun to reflect off. So they don't reflect as much sunlight. So basically you're seeing further down into the atmosphere of Jupiter in the darker sections. And we don't actually know why there's so many different structures on Jupiter in the atmosphere. And we believe the energy for these structures is coming from the lower atmosphere, but we don't actually know how that could be done yet. So that's something that could be found out in the future. This is another picture of Jupiter. This is an older one, so the colours aren't so vivid. But it just shows the atmosphere again, and we reckon that the clouds are about 50 kilometres deep. Before you get to the next level of Jupiter's surface, and I say surface lightly here because again it's a gas planet. We believe that there's water vapour underneath the ammonia cloud cover, and the orangey brown bits, so these kinds of different colour belts, we believe are made from sulphur and ammonia, but when they get irradiated by the UV light of the sun, they actually change colour because they react with the light from the sun. And the equator gets a lot more sunlight than the poles do because of the tilt of Jupiter towards the sun. So that's why those colours are slightly different to the main bits of Jupiter. And Jupiter has some really interesting moons itself. Io is one of them. It's 100 times more volcanically reactive than the Earth. And you can see one of the volcanoes here spewing out lava and magma and dust and all kinds of stuff from its surface there. And it can eject up to 50 kilometres of lava and 500 kilometres of dust and gas from the surface of Io. So that's from here to Manchester probably. So it just shows how reactive Io is. And it really is a fiery hell. Venus is kind of a horrible place to live, but Io is really a fiery hell. It's not very nice at all. And there's a mission on its way to Jupiter at the moment, the Juno mission, which left in 2011, and it should get to Jupiter in 2015, so keep an eye out for that. It's going to do 33 orbits of Jupiter and find out more about its composition and a bit more about the moons as well. And there's actually 3 astronauts on board. I bet you hadn't heard about those. They're not humans, unfortunately. They are Lego people. Galileo, Jupiter and his wife Juno. And normally Lego's made out of plastic, but to survive the mission to Jupiter, these guys are actually made from aluminium. And they are made by the real original Lego designers, so I think that's quite cool. So the first astronauts to Jupiter, the first human astronauts. Okay, so this is Uranus. Obviously we don't know as much about Uranus as we do about the inner planets because it's so far away, but we do know it's knocked. It's been knocked in its past, like by an asteroid or a comet or something, which means it's actually been tilted almost 90 degrees to the sun. So if these are the poles, if these are the poles, the north and the south, and you've got a ball orbiting around there as Uranus, it got knocked like this. So the North Pole and the South Pole are the things that point towards the sun, which means that at the poles, you get 42 years of darkness, followed by 42 years of daylight. So if you lived on the poles of Uranus, it would be pretty chaotic. And its equator, even though it's been knocked by 90 degrees, the equator is hotter than the poles are. But the poles are, even though the poles are facing towards the sun for more of the time. And we don't actually know why. It's a bit of a strange one there. And Uranus is so far away from, I'm just going to clear a space. Uranus is so far away from the sun that the temperatures are very, very cold indeed. They are approaching about minus 220 degrees. And just to show you how dangerous it could be, I've got my, did that on purpose. I've got a little container full of liquid nitrogen, and I've got my astronaut here in his flight suit, and I've got 2 balloons which I'm pretending are lungs, in case you were wondering what these balloons were. So we've sent our astronaut to Uranus. It's really, really cold there. Remember the astronauts that went to Venus? They got squashed and compressed and stuff. If your lungs were on somewhere like Uranus, I'll put my glove back on just in case. Where's it? Oh, yeah. If your lungs went to Uranus, or if you went to Uranus, this is what could happen to your lungs because it's so cold. I'm just putting the balloon in. And because it's so cold, the air starts to change state. And as you can see, the balloon actually starts to deflate until it's almost completely deflated. But then when I take it out again, back in room temperature, there's a bit like a little magic trick. It starts to inflate again. And we can watch that. We can watch that in a minute. And I wonder if I can freeze some marshmallows. Frozen ones? I froze a banana once using liquid nitrogen and then ate it too quickly and burnt my tongue, so I'm not going to eat them. Pretend these are astronauts again, like we did before. Just pour out the liquid nitrogen back in here. And I'm not a very strong person. There you go. So just imagine if our astronauts went to Uranus, it wouldn't be very fun at all. So basically, I think we should stay on Earth. I've made a mess now on the table. I've got one more trick coming in a minute. Right, we've got lots of liquid nitrogen. We might be able to play with it at break time. Okay, so that just shows how cold it is in the outer planets and how dangerous it would be for astronauts. Not to mention the 42 years of daytime and the 42 years of night as well. It wouldn't be a particularly nice place to live. Moving on now to Neptune. Neptune's another very, very cold place, and we believe one of the moons actually has liquid nitrogen on its surface, but we don't know that for sure yet. Neptune, we believe, has a rocky core with an 8,000 kilometre atmosphere made from things like ammonia and possibly liquid nitrogen as well. And it's about minus 220 degrees C at the equator, so it's another very, very cold planet. Neptune's kind of funny because it has spots on it, a bit like Jupiter. So Jupiter's got the Great Red Spot. Neptune has got the very imaginatively named Great Dark Spot and Small Dark Spot. Scientists not very good at English, obviously. The other thing that it does have is this thing here, which is called the scooter. And the scooter is a windstorm on the surface of Neptune, which is going so fast that the distance the speed it can travel is about 2,000 kilometers per hour. Just imagine, most cars go down the motorway at 60 or something like that. That is traveling at about 2,000 kilometers per hour. So that's pretty insane. And then we have Pluto and its sister planet Charon. It could be a moon, could be a binary system, depends how. I call her Sharon. She's my mate Sharon. And there are some other small bodies around Pluto as well. And hopefully in the years to come we'll learn a bit more about Pluto as well because of the New Horizons spacecraft, which is on its way. It's the one that took that picture of Jupiter before. It left in 2006 and it's supposed to get to Pluto in 2015 as well. So there's one that's going to Jupiter and the one that's going to Pluto. Keep an eye out for both of those because that will be really interesting when they get there. So now we have a whole bunch of extra things in our solar system. We have all the dwarf planets, like Pluto and Eris, Sedna. I can't even pronounce half of these. But it's really interesting because we're relabeling all the different things in the solar system, we're starting to get a new solar system, which is probably very different. Well, not different so much to the one you might have been taught about, but is very different to the solar system that I was taught about when I was at school. Pluto was still a planet. We didn't know about Eris and Ceres and all of those types of things. But now we certainly have the new solar system and all the different things that are in it. And we don't just have planets in our solar system. We have objects like comets as well. And comets are basically massive snowballs hurtling through space. And they have an elliptical orbit, which is kind of like this one here. And when they're in the extremities of their elliptical orbit, they're very dark, not very reactive bodies, so we can't, apart from the fact that they're very far away, we can't really see them because they're so dark. But as they come towards the sun starts to melt the comet, and the comet grows these fantastic tails, the ion tail and the dust tail. So as they do come closer to the Earth and the sun, we can start to see them. And we know quite a lot about what is in a comet, because of because of missions like the Deep Impact mission, which had a main spacecraft and a probe which hurtled into the surface of Comet Tempel 1, and as it went into the surface of the comet, it actually flew up some ejecta which was collected and analysed. And because we know exactly what's in a comet, we can make a pretty good analogy in the classroom or lecture theatre as we are today. I'll do it over here actually, I've laid it all out. So, we know that we have water in a comet, and I've put some water in this bag already. We know that we have carbonates in the comet, so I'm going to use sodium bicarb just as an analogy there. We know we have ethanol or methanol or some kind of alcohol in a comet, so I'm giving up my Saturday night vodka for the name of science there. There's also ammonia, which is found in nail varnish remover. So we'll put a glug of that. And we know that there is organic materials, so Lee and Perrins, to signify my organic materials in there. And we also know that there is sand or silicates in a comet, so put that in as well, smelling like quite a nice cake. And we have the stuff that makes it cold, if I can find my scissors, which is carbon dioxide ice. Has anyone ever seen dry ice before? A few of you. It's used in smoke machines, Halloween type things, cocktail drinks, but don't ingest it until it's melted. It's safe, once it's melted, but it's very, very cold. It's not as cold as liquid nitrogen. It's about minus 80 degrees, and it is solid carbon dioxide. If I whack a bit of that in here. What you see here is the carbon dioxide reacting with the water and actually letting off vapor, carbon dioxide vapor. Carbon dioxide is heavier than air, so instead of floating up, it all sinks and floats away like that. Might need another jar of that. Okay, we'll just let that react for a bit. And the reason that comets are so important in our scientific knowledge is because, well, one of the reasons is because we think that comets are very similar to what the Earth was like millions of years ago. But because comets live so far away from the sun, they haven't changed that much over time, whereas obviously the Earth has. So if we can find out what comets are made from and how interesting they are, then we can find out more about primordial Earth as well. So that's one of the reasons that we want to know why comets are made from what they are. And we also believe, well, one of the theories at the moment is that the Earth used to be very barren and without water, in fact, and without organic materials. And the current theory is for the origins of life and water on Earth is that you had this barren Earth and this massive comet came and crashed into it. And because it crashed, it melted, sort of letting out all these organic materials, not unlike the Liam-Perrins, and letting out all the water. And actually, because of the comet collision, that's why we've got water and organic materials on the Earth. Now, obviously, that's just another theory, but whether it's true or not, we'll hopefully see in the future. Now, let's have a look at this comet. You can see the gas tail. Ooh, see if it comes out. It's hard to do these things with gloves on. So you can make this comet as well if you get some dry ice, or a massive freezer and some normal ice. And there we go. That's a pretty realistic analogy of what a comet actually looks like, except this comet's only about 20 centimetres across, but most comets are about 50 kilometres or more. And you might be able to hear the fizzing and the bubbling as the comet reacts with the air. And that's pretty much what a comet would sound like as well in space, as it reacts with the sun's rays. And you can see the gases that are coming off this comet. And imagine if I chucked it, I won't, but imagine if I chucked it, you can imagine that the gases would all come out of the end of it because of the speed that it was travelling at. And that is a really good analogy for the tail of the comet as well. So this is about the only planetary type thing that we can make quite accurately in a lecture theatre. Everything else is all kind of pictures and diagrams and stuff. So it's quite nice to be able to make something like that. Ooh, losing the Liam-Perrins. Yeah, so it's quite nice to be able to make something like that. Don't worry, it's safe in the classroom. So there we go. Okay, now we haven't talked much about the sun because this talks about the solar system but not the sun specifically. But I had to show you a couple of pictures of the sun because it's the hub of our solar system. Without it, we would not be there. And this picture is a coronal mass ejection an outpouring of really, really hot plasma and particles from the sun. Something this big happened last February, not this February, but last year, February. And the sun, when it's active, it can often be this dramatic. And just to put this into perspective, that's how big the Earth would be in relation to that coronal mass ejection. And luckily, we've got a magnetic field to protect us from the solar wind and these particles coming off the sun. But if we didn't, stuff like that would annihilate us on a regular basis. So we're quite lucky that the Earth is magnetized. When the sun does start to go on to the next phases of its life, it will become a red giant. And as it does so, it's going to get much, much, much bigger and much, much cooler. So first of all, because it's a lot cooler, a lot of the things that depend on sunlight on the Earth will start to die. And eventually, as the sun gets very big, it will swallow the first 5 or 6 planets as it goes along. So we are going to die because of the sun, if not for other reasons, in the future. But luckily, not until about 5 billion years. So we should be okay for a little bit longer. And by then, hopefully, we found some exoplanets to go and live on. And exoplanets were an idea that started to, well, obviously people thought about them years and years ago, but in the late 90s, we started to believe we could see things like exoplanets. And the first sighting was in a constellation called Vega. When we looked at Vega in some different cameras, and we're seeing what we thought was a disk of material orbiting the star. And initially we thought it was a protoplanetary disk, so a region that planets could actually form. Eventually, in 2005, we realised it wasn't actually a protoplanetary disk, it was just accreted matter from the star, probably like an asteroid that broke up or something like that. But it got our excitement about exoplanets really, really flowing. And since then, it's been quite interesting how much we found outside of our own solar system. So there's the Kepler mission, which has been going for about a year and a half now. And the Kepler mission so far has found 300 stars outside of our solar system that have planets orbiting them, over 700 planets outside of our solar system, and they're all quite important and quite exciting. There was Gliese 581, the star, which has a solar system of about 5 planets orbiting it, and 581d is the one that's particularly interesting to us because it's about 5 times the size of the Earth. It's about 20 light years away, so it's pretty far away, but it was the first terrestrial mass exoplanet found, and particularly in the habitable zone, which is the zone that we believe is the place that we'd want to look for aliens and things, because it's just far away enough from its star to not be burned alive, but not far away enough that it would be too cold like Uranus and Neptune. And then we had, what's it called, HD 5512b, sorry, which is 36 light years away, but only 3 times the size of Earth. So we're getting closer and closer to finding an Earth mass planet outside of our solar system. And that's actually the smallest exoplanet we've found so far using the Kepler mission. So if we could go there, we don't really know what we could see, but it could be something quite exciting. And then last year, there was the Kepler 22 system, which found a planet orbiting a star very like our own star, which was quite exciting. Not only orbiting a star like ours, but orbiting at the same distance as the Earth. So everyone got really excited. Have we found second Earth? You know, there was all kinds of headlines in the Daily Mail and stuff, and everyone got very excited. 2 problems with this system. First of all, it's 587 light years away, so it's a bit far for us to go to. And secondly, partly because it's so far away, we can't exactly tell what the planet's like. Mathematical modelling has shown us it's either about 10 times the size of Earth or about 3 times the size of Neptune. If it is the size of Neptune or similar to the size of Neptune, it would be very similar to Neptune in its composition and its temperature and things like that. But if it is more like Earth, and if it does actually orbit where it does, and if it has an atmosphere like us, the temperature on this exoplanet would be about 22 degrees C, which is very similar to the surface of the Earth in countries that aren't England. So that's pretty exciting. I know it's not far away. I know it is far away, and I know it's all mathematical modelling and lots of what-ifs, but it just goes to show what we can achieve with planetary science and with exoplanet science in the future. And the possibilities really are endless. And because I'm talking to physicists in this room that have a lot more years on me, you could be doing stuff like this if you go into physics in the future.